So from 450 to 730, that's 95%. Now, they said how many students, though? There's 2,000 students total. So we got to take 95% of 2,000 students, don't we? So that means 0.95 times 2,000, get 1,900 students got scores in that range. That was answer B. Does that make sense? Is that good? Do that on the final exam tomorrow. The fifth exam is really all it is tomorrow. Questions I can answer? Good, okay. So we go. Okay, and there's not much. So, okay, so these coin flip, die roll things, it's going to end up being normal curve, all the stuff's the same, except I gave you those two formulas, right? Those two formulas were what? There it is. The mu is n times p, and the sigma is the square root of n times p times 1 minus p. So that's what you always do on the coin flip, die roll questions, just like that, right? That makes sense? That where the p is the probability. That's what that stands for, the probability. Thank you, Jenna. So that's the probability, and the n is the number of times you do whatever, flip the coin, roll the die, whatever, and p is the probability of whatever you're trying to do. Get a heads, get a whatever number on. They'll tell you. So like in this question, honest die, rolling a die. What do they mean by an honest die? What do they mean by an honest die? Ever heard that phrase before? A die that doesn't lie? I mean, what's an honest die? Don't lie to me, die. Don't lie. I mean, what does that mean? Do you guys know? You ever heard that? No, there's all kinds of different sides. Some are honest, some are not. You guys know about all the corruption in the world of gambling and all that? You know, they can put weights inside of a die. And so if they weight one side, then that side will tend to be heavier and tend to go down, so the other side will come up more often. So it's not equal probability for all the 6 numbers if they put weights in there, right? Guys are so removed from all that. I'm glad. That's good. And it's honest. Yes, that's it. So they're saying it's an honest die. It's got no weights in it to make it do something false, right? I'm not saying the casino industry does that. They don't need to. It's all honest, I'm sure, because they know the probabilities of winning. Let the random variable represent the number of times a 1 is rolled. So there's what we want to do. So they'll tell you it's something. You want to get a heads, or you want to get a 1, or whatever it is. And there's that 68, 95, 99.7 that I just showed you. It just means normal curve to figure everything out. Okay, so what are we doing? So the number of times we're rolling the die is a lot, 2,880 times, and p is the probability. Of what we want, which is getting a 1. What's the probability of getting a 1? And it is 1 out of 6. Is that good? Probably is 1 out of 6. Good on that? So probably is 1 out of 6. All right. So there's our p. There's our n. So now we can get our mu. Our mu is n times p. So that'll be 2880 times 1/6. Just use your calculator. 2880, times 1 divided by 6. I didn't bring my calculator. Somebody have that? I think it's 36. 36? No. 480. Okay. 480. All right. You know what that is? That's the number of times we expect to get a 1. Really, 1/6 of the time. That's basically divided by 6. So you expect to get a 1/6 of the time, right? Like that, all right? And sigma, use the formula that's up there, square root of n, p, 1 minus p. Does everybody see what that is? So if you expect to get a 1 480 times, 1/6 of the time that you roll the die. And it's funny, I was just yesterday afternoon, was it yesterday? Yeah. I was talking to my oldest son about, I was talking about the gambling thing and how I'd been lecturing on it. And I was, I'm going to Las Vegas next week with my wife, and I was joking around about it. I'm like, hey, Daniel, you think I should do that gambling? Anyway, this funny thing we've always joked about in our family for years and years. And he's like, no, that'd be crazy. And he said, anyway, Dad, he said, minimum bet there's $20 a table. I'm like, really? I'm like, how do you know that? And he's like, remember I was there. He was there he's on the Fresno State Frisbee team, and they took a trip a couple months ago to Las Vegas to play. And I'm like, oh, yeah, that's right. I said, did you go in and do something? He said, yeah, me and my buddy, we went in. And he said, let's both they took $20 and he said, let's one of us put it on red. They went to the roulette table. One of us put it on red. The other put 20 on black. I don't know if you know how roulette works, right? Got all the things red and black. But there's one green 0 and one green 00, but all the rest are red and black. And he said, one of us will win. We're just having fun. One of us will win, and just one time, and we're out of there. So boom, boom. He said they rolled the thing, and it came up green. No. We both lost. He said, isn't that Las Vegas? I'm like, yeah, it's Las Vegas. There you go. That's exactly it. All right. So square root of NP, 1 minus P. So throw them in there then. N is the 1/6. No, I'm sorry. N is the 2880. N is the 2880. P is the 1/6. And then 1 minus a 1/6. Like that. Like that. That good? So just hit all the buttons on the calculator. You might want to start, probably easiest to start right here. Just go 1 minus 1 divided by 6. I don't know, do whatever you want, but it'd probably be easier to start there, and then you could go times 1/6 times 2880, square root when you're done. Anybody? Can I use your calculator real quick? So I'm glad to help if you have trouble getting this. You guys getting 20? 20 on that. Do you know how to get that? Is that giving you any trouble? Anything I can say? All the calculators are a little different, so how about just come on up after. When we break here, I'll be glad to help you. 10 seconds, I'll be able to help you do that. But I could say this is probably easiest to start with a 1 minus 1/6. Anyway, you can start anywhere. Square root. So 20. So I've got a mu, that's the middle of the curve, and I got the jump amount, right? So the middle of the bell curve is going to be 480. The lines are going to be jumping by 20. The rest is the same. I'll do it. But once you've got those, that's the only part that's different on these dice roll, coin flip ones, is you just got to use those two formulas to get the mu and the sigma, the middle, and the jump amount. And the rest is draw the curve, blah, 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 blah. So I'm gonna do the same thing and bring it over here. So now we know the mu is, well, I already forgot, 480. Okay. And the sigma is 20. All right, and then all right, so then there's the middle. The middle is 480. And then the jump amounts are all 20. So 1, 2, 3 jumps to the right, and 1, 2, 3 jumps to the left. Like always, every jump is going to be 20, so we just add 20, add 20, add 20, right? And then subtract 20 the other way. Subtract 20, subtract 20, subtract 20. Put in the percentages, 34%. Percentages are always the same, right? The only thing that changes from example is numbers on the bottom. So let's put those in there. Okay, and now what's their question? So we already answered the first two. What's the mean? What's standard deviation? Oh yeah, the answer was right there. I didn't even know it's 20. Okay. So anyway, probability that a 1 will be rolled more than 540 times. So 540 is right here. So more than 540 means that way, huh? So what's the probability that you're going to get more than 540 ones? 0.15%. They want you to change it to a decimal. So 0.15%, move it back 1, 2. That's why it's 0015. See how the answer is right there? Because they want a decimal. 0015. And they even put a 0 in the front. You don't have to, that's optional. Is that good? Does that make sense on that part? So the probabilities are up here. That's what that really means. That means if you're going to roll a die 2,880 times, the chance you're going to get 540 or more ones is very, very low. Very, very low. Now, what's the probability that you'll get a 1 somewhere between 480 and 500 times? 480, 500, right there, 34%. Or 0.34 decimal. Is that good? Those pretty easy. So it's the same normal curve, just you got to use the little formula to find the mu and the sigma, the center and the jump amount. So it's kind of interesting. That's what I was saying. That's what the casinos, that's why I say it's a science for them. They know exactly. They know this normal curve. They know the probability that people will get this, that, and the other thing. And they know when, when everybody's playing the games, 2,000 dice are rolled. They know that what's going to happen. They know exactly. That's why it's such bald-faced lying to say, win big and da-da-da. No, they know exactly. They know exactly what's going to happen. It's a science. Make sense on all that? That all good? Important. Let's take a quick look. So number 8. Okay. Distribution. Oh, no, I need to click that thing. That's right. All right, so there we go. So distribution of weight, 6-month-old baby boys, approximately normal, mean, standard. Suppose 6-month-old baby boy weighs in the 95th percentile of his age group. Estimate his weight. Estimate his weight. Well, that's easy. Just look at the table. They're given, this is the little table I clicked on. 95th percentile. Just grab that formula. This is a real easy one. Mu plus 1.65 sigma. Just simply grab the formula that they're giving you there. So 95th percentile. I'm kind of out of room, so I'll do it right here. 95th percentile. The formula is right here. It's mu plus 1.65 sigma. What's mu? Well, they're telling me right here, mu is 15.75. So 15.75 plus 1.65 sigma. Sigma's 2. They gave it to me right there. So just plug those in, hit the buttons in your calculator. Nothing more fancy than that. And I don't know what the answer is. It's going to be 18 something. 18.85 maybe? No. 3. Or is it 19.05? I can't tell.
Yeah.
19. Is it 19.05? Okay. 19.05. Does that make sense how we got that? They just said 95th percentile. They gave me this special table, and I clicked the button, which gave me the formula, mu plus 1.65 sigma. They gave me the mu. They gave me the sigma. Just plug them in. Hit the buttons on the calculator. Good on that. And then part B says 10th percentile, same thing. Grab the formula, type it in. I'm going to skip to another one if that's okay. Same kind of thing. Okay. So this one, instead of giving you the percentile, they're giving you the final answer. And they want you to work back and say, hey, which of these formulas did we use? So, right, so they're saying Henry, little Henry, is a 6-month-old baby who weighs 23.05 pounds. Which percentile was Henry in? See, they're giving the answer, work backwards to the percentile. Well, how do we do that? And up above, again, they're giving me the mu, they're giving me the sigma. So you kind of got to like guess and plug in, guess and plug in. Let's guess wisely, though, to kind of speed things up. If Henry weighs 23 pounds, is he bigger than average or smaller than average? Let's start there. So 23.05 pounds for Henry, little Henry. So is that bigger or smaller than average? What's average? Average is right there. Average is the mu, right? Mu means, it's a Greek M for middle. Or mean, means mean, but whatever, we'll say middle. Same thing. It works. That's the middle. So the average baby boy is 19.75 pounds at 6 months. So Henry's bigger than average. So what does that mean about his percentile? Well, it's going to be more than 50. It's going to be one of these, not one of those. It's going to be more than 50%, not less than 50%, right? Remember what percentile means? Let me keep reminding you of that. That's important. Percentile equals percent below or to the left, right? So if you're at the 70 percentile, then 70% of the baby boys weigh less than you. It's always percent below, isn't it? So if you take some big fancy standardized test like the SAT or whatever, GRE for graduate school, and they say you got at the 59 percentile on that exam. What does that mean? Should you think, oh man, I blew it, I failed. 59%, that's an F. No, what does 59 percentile mean if you take the GRE or SAT or something? 59% got worse than you. You're better than average. Does that make sense? 59% got worse than you. So you did better than average. You did better than half the people did, better than 59% of the people did. So, right, percentile, percent below. So if Henry's bigger than average, which he is, 23 pounds, then his percentile's above 50, because more than half are below him. So he's one of these. Okay, so which one, though? That helps a little bit, I guess. Which one? Well, can we kind of guess? How many jumps above the middle? If the middle's 19, Henry's at 23. He's about 2 jumps above the middle, isn't he? Well, that's about 20. So he's about a jump and a half, right? Because a jump is 2. He's about a jump and a half. I don't know. I'm just sort of guessing at this point. You just got to guess. So I'm going to try one of those. Maybe, I don't know, jump and a half. Let's suggest. So jump would be 34. That'd be 84. So he's above 84. He's probably 90. So I'm going to try the 90. So I'm just going to guess. You see what I just did in my head there? I said Henry's more than, right, if you took 20, that's basically 20. Add 2, that's 22. That's 1 jump to the right. If I was to do a normal curve, and say here's the middle, which is 19.75. 1 jump to the right would add 2, would be 21.75. Well, Henry's even bigger than that. He's at 23. Well, how much percentage is there? There's 34% here and 50 here. So he's above the 84 percentile, I know. See how I know he's above the 84 percentile? That's why I'm starting at 90. I'm thinking, he's probably 90 or 95. He's above 84 percentile. That's what I'm doing. So I'm just guessing. So is he that one? I don't know. Let me try. So maybe he's that one. Mu plus, what is it? 1.28 sigma. So I'm just going to stick the stuff in and see if it comes out to be 23.05 pounds. So put in the 19.75. 19.75. Put in the 2 for sigma. So 2.56. Is that right? I think that's right. Isn't that 23.05? I'm just going to hope. Tell me that's 23.05. That looks like it to me. That's right? Yeah, so I got it, but it's a pretty good lucky guess there. So the answer then they want is they want 90th. They were asking what percentile is Henry at. He's at the 90th percentile, meaning 90% of the kids are lower weight than Henry. So now if I had been wrong, if that had been the wrong guess on the first guess, if it was too low, I would have went higher. If it was too high, I would have went lower. Just keep guessing until you get the one that matches, right? It came out 23. It came out Henry's weight. So that was the right formula. When I plugged in the mu and the sigma, it matched Henry's weight. So that's the formula they must have used. He's at the 90th. Make sense? We're just working that table backwards. If I'd been wrong, if I'd been too low, I would have went higher. If I'd been too high, I would have went lower. So you can get it 2 or 3 guesses. That good? On that, can I flash off that? Wrongly. What did you get? 22 what? 22.31. Okay, so I'm wrong. That's too low. That's too low. So, because he's supposed to be 23, so you got to go higher. So higher than 90, go to the next one up. And that would be this formula, which is for 95. So I was wrong. So I went higher. So try that one now. So mu, which we know is right because we just saw the real answer. So, but let's do it anyway. Mu plus 1.65 sigma, right? Plug in mu. Mu again is 19.75. Everybody see what I'm doing there? I don't know if you can see these little numbers. You'll be able to see it when you do your homework. Sigma is 2, and that one does indeed come out to be Henry's weight. 23.05, so there's where Henry is. Henry's really at the 95th percentile. Is that good? That makes sense? So you just keep guessing until you get it. Find his percentile. That's the one for Henry. All right.